Hello, in this video we'll be going over the sorting algorithm Insertion Sort, its characteristics, a demonstration, and implementation for the code. Insertion Sort. It treats input as a sorted and unsorted part, and the comparison is made with a for and while loop. It takes an array A as a parameter, but also works for larger data types. It has the complexity of big O and squared. This is because it has two loops. Here's the algorithm for Insertion Sort. As you can see, starting on line 3, we have the for loop, then on line 5, we have the while loop. The while loop's Boolean statement has two Boolean factors. J must be greater than 0, and A at J must be less than A at J minus 1. On lines 6 through 8, you can see we have a swap. Moving forward, we can now pay more attention on the while loop, since this is the most important part to understand. The first thing we're going to do is initialize I. As you can see, on line 3, int I is initialized to 1, and int J is initialized to I. This means J will be equal to I, or J will be equal to 1. We can now check the Boolean statements. Is 1 greater than 0, or is J greater than 0? True, it is. And the second statement, is A at J less than A at J minus 1, or is 15 less than 23? True. This means that we're going to swap and de-increment J. Now J will be at index 0. Since 0 is not less than 0, the Boolean statement is false. It ends that iteration, and I will increment by 1. This means the index for I is now 2. J is equal to I, which is index 2. And we begin again. Is J greater than 0, or is 2 greater than 0? True. And is A at J less than A at J minus 1, or is 1 less than 23? True, it is. This means that we're going to swap and de-increment J. Now we're going to check again. Is J greater than 0, or is 1 greater than 0? True. And is A at J less than A at J minus 1? Now we're going to check again. Is 1 less than 0? True. And is 1 less than 15? True. This means we will swap, and J will de-increment, which means J will now be equal to 0, making the Boolean statement false and starting another iteration for I. This means I will now be equal to 3, J will be equal to I, which is 3, and we begin again. Starting, we have, is 3 greater than 0? True. And we have, is 15 less than 23? True. This means we will swap and de-increment J, which means J will now be equal to 2. Now we have, is 2 greater than 0? True. And is 15 less than 15? Not really. This means that the Boolean statement is false, that iteration is done, and I will increment to 4. J is equal to I, which is index 4, and we begin again. Is 4 greater than 0? True. And is 30 less than 23? False. This means that this iteration is done, and I will increment. I is now equal to 5, J is equal to I, and so J is equal to 5. Now we ask the question again. Is J greater than 0, or is 5 greater than 0? True. And is A at J less than A at J minus 1, or is 8 less than 30? True. This means we swap and de-increment J. Now J is equal to 4. Now we have, is 4 greater than 0? True. And is 8 less than 23? True. This means we will swap and continue to de-increment J. J will now be equal to index 3. Now we have, is 3 greater than 0? True. And is 8 less than 15? True. This means we will swap and J will de-increment, which means J will now be equal to 2. Now we have, is 2 greater than 0? True. And is 8 less than 15? True. This means we will swap again, and J will de-increment so that it is now equal to 1. And now we check, is 1 greater than 0? True. And is 8 less than 1? False. This means the statement is false, and I will increment. I is now equal to 6, J is equal to I, which is index 6, and we begin again. Is 6 greater than 0? True. And is 3 less than 30? True. This means we will swap, and J will de-increment. J is now equal to 5, and we ask again. Is 5 greater than 0? True. And is 3 less than 23? True. This means we swap, J will de-increment, which means J will now be equal to 4, and we begin again. Is 4 greater than 0? True. And is 3 less than 15? True. They will swap, and J will de-increment. J will be equal to 3, and we now have, is 3 greater than 0? True. And is 3 less than 15? True. This means we swap, de-increment J. J will now be equal to 2, and we now have, is 2 greater than 0? True. And is 3 less than 8? True. Swapping and de-incrementing J so that it will now equal 1. We now have, is 1 greater than 0? True. And is 3 less than 1? This is false, meaning this iteration is done, which was the last iteration, and the array is sorted. Moving forward, we will have the implementation for the code. We can now begin the implementation. First, I'm going to create a class. I'm going to save it to my directory, and now I will create the main. I can now create the array. For the actual algorithm, I'm going to put it in its own method. Since this method is only going to modify the array that already exists, it will be void. I will call it insertion. The only parameter it will take is an int array. Now I'm going to create the for loop. Remember that I is initialized to 1. I will initialize j to I, and now create the while loop. Inside of the while loop, I will have 2 Boolean expressions. J must be greater than 0, and a at j must be less than a at j minus 1. If both of these things are true, we will create the swap. This means we will create a temp variable. After that is done, we need to de-increment j, and now call the method from the main, pass the array to it, and create a print. I want them to print on the same line with a space. This means I will use a system out print, no ln, a at I concatenated with a space. Then I make sure to eat the last line with a system out print. I save, everything looks just about right, and now I can compile and run. I can now run it, and I received an error. Be sure to read over your code. As you can see here, I put plus plus instead of minus minus. I will save that and run it again. As you can see, the array is sorted. I hope this is helpful, and happy coding!